All right, everybody, last sections for the year. We wanted to kind of cover two things today, and they're not terrible. A lot of it's going to use your calculator. So if you have a TI calculator handy, that might be really useful to have, and hopefully you've already printed out these notes. The first thing we want to mention, and I think I briefly mentioned it before, was something called the common log. So the common log is a logarithm whose base is 10, as you can see here. It's written without the subscript 10 for the base. So you know like how we write, oops, if I'm, there we go. How we write like square root, but we don't put the little 2 here because we use the square root so often. This is the same thing with log base 10. We just write log like 5. We don't put the base here. There's no b because we use log base 10 so much. This is the button that's on your calculator. Okay, so if you see a log without a base, you know it's the common log, which is log base 10. So things like this, log of 4, log of 5, log 10, of 12, etc. Okay, so you don't see the base, so you just assume it is base 10. So something like this, you could just type in your calculator, find that log button, then put 8 in the parentheses, and hit enter, and it'll give you 0.903, probably more than that, but it gives you whatever the decimal value is of it. So anything that's log base 10, you could just type right in. Log of 32 is going to be 1.505. So let's try doing some of these together. What is log 14? So again, just typing in log 14 on your calculator. Let's go 3 decimal places. I got 1.146. And log of 12, same thing, just kind of type it into your calculator and you should get 1.079. Okay, so that's not too bad. Um, but let's say you're given something that isn't log base 10 and you want to change the base so that you could put it in your calculator. Now, a lot of the newer TIs, or if you have the updated operating system, um, you can put in uh, the log base, whatever, in the calculator. I'll show you how to do that in a minute. But if you don't have that, we do have this change of base formula, which will allow us to take and change whatever base we have to anything really, but usually we change it to log base 10 because 10 is the one that's on the calculator, right? So it's easy to convert it. So like, let's look at the example, and I think it'll make a little more sense. So I have log base 4 of 65. I don't know how to solve that. Even if I tried to put it in exponential form, it might not work out very nicely, right? It's going to be some decimal value. So if you use the change of base, it's always the log of the argument. So the log of m, the top part here, over the log of the base. Think the base goes in the basement of the fraction. So this turns into log of 65 over log of 4. And you would just plug those in the calculator separately. What is log of 65? You get the 1.813. What is the log of 4? You get 0.602. And when you divide that out, you get 3.011. Okay? And you can see right here, you could type it in your calculator like this, the log 65 divided by log of 4 to get that answer. Okay? So let's try one together. So if we had, oops, sorry, log base 2 of 24, remember log of the argument over log of the base. Okay, so this would turn into log of 24 over log 2. And then you would type that in your calculator just like you see it there. Log 24, typing it into mine now, divided by log 2. And you get, I got 4.58. I'm going to round it to 5. Okay, you try number 2. Okay, so hopefully you gave that a try. I turned it into log of 52.6 over log of 3.5. And then again, I put this in the calculator. If you are going to put it in all in one like this, make sure you close that parentheses right there. Otherwise, it puts this inside the log over here. So just make sure you close that parentheses. Okay, so hopefully that makes sense. Let's skip down to I think I want to go to page, it's 25. Okay, let me just check and make sure. Yeah, page 25. There's a couple others in there if you want to take a look at, you can, but we're going to skip down to page 25. Okay, so with um, this is 10.5 is natural logarithms and base e. So remember, logs can be any base. Um, they can be base B, whatever that represents, or base 10, okay? Natural logs are special because they are base E. E is a number on the calculator like pi. It's a transcendental number. It doesn't have an end. Um, and it's an irrational number. And if we just go to the calculator again, you'll see it above, you'll see log, and then right below it is ln, and in between in the blue is e to the x. So if you just put in e to the 1, okay, so if I put in e to the 1 on the calculator, I get like 2.71828, etc. Okay? We use this for like exponential growth and decay or calculating like interest on some word problems and things like that that we'll get to next year. But basically, this is a special number that comes up a lot. And when we do a log base E, we give it a special name, which is the natural log. So ln. Okay, it's still a logarithm. It still has all the same properties, okay, like the way that logs work. Just because it's a special base, it gets a special name. Okay, and if you see ln, you know that's base E. So you don't have to worry about doing change of base or anything like that. You can just use the natural log instead. So here you can see that we can say ln of x equals y, just like we said log base b of x equals y. And that would then convert to e to the y equals x. So this would be that definition of a log that we talked to in a previous section. But now just doing it special for natural log, and the base is always e. Okay? And all the other properties work as well. So for example, like the product property where we had ln of x and ln of y. Remember before, if we saw addition, we just multiplied our arguments. Same thing happens here. If we did the subtraction one, ln of x minus ln of y, we would still get natural log of x over y. Remember, everything's the same. It just looks different because we have that special base. So p times ln of x, remember this is where we multiplied by something, we made that ln of x to the p. If anything, these are faster to write, fewer letters. You don't have to worry about that base b because we already know what the base is. Okay, so all of these properties still work. So anything you could do before, we can solve in a very similar way. We just know that the base is e. Okay, so let's go on to the next page, page 26. So this is what you're going to be doing for homework. Let me just kind of talk you through some of these examples so that you can realize how you're going to solve it. But for numbers 1, 2, and 3, you are literally just going to go into the calculator and hit that second ln button on your calculator and then put in whatever the exponent is, and you're going to tell me the answer. So for example, if I did second of e to the 0.5, I get 1.64. I'm going to call it 9. Give me like 3. Oh, oops, sorry. 4 decimal places. Call it 8, 7. There we go. Okay, so you do the same thing for the others. All calculator for questions 4, 5, and 6. So instead of hitting second natural log, you're just going to hit natural log of 5 and hit enter. And same thing, 4 decimal places. So 1.6094 is what I got for that one. Okay. For this next section, they want you just to convert from the log to the exponential or the exponential to the log form. So let's do this one. Remember, these are rounded, so you can treat that like an equal sign, but they want you to realize it's not exact there. So if we have natural log, we know it's going to be e to the y. Sorry, I can see my 3 there. Equals x. Okay, so just using that definition. So that would be y equals ln of x if and only if e to the y equals x. And for these, um, when you have a little extra hint here, when you have like e raised to the natural log or the natural log of e, that's like squaring and square rooting something, right? They kind of undo each other. So for example, if you have e to the x, oh sorry, e to the ln of x, oops, did I get my eraser there? Yeah, okay. If you have e to the ln of x, it just equals x. And if you have ln of e to the x, it just equals x. These two things here and these two functions here are canceling each other out. All right. So let me pick one that looks the hardest here. So like on this one, number 11, when you're doing the natural log of e, those are going to cancel each other out. So you're left with just the x squared minus 1. Okay. So same thing for these two. So make sure you remember those properties. Maybe jot them down on your paper. All right, and then these are solving, just like we did with the others. So using some of the properties or the definition to try to solve. So let me pick one. How about um, I'll do 17 and 18 with you. Okay, let me start with 18 because this one looks the most like what we just did. So remember, it doesn't matter that it's natural log and not log, works the same way. We see the subtraction, so I know I'm going to do natural log of 5x plus 4 over 3 plus x equals natural log of 3. But since they're both natural log of something, we know those two somethings, the arguments have to be equal to each other. Okay? Works the same way. You know how to do this if you've been keeping up with everything. So I think you could solve it from here. You'd cross multiply, etc., to get your answer. 17, same thing. Just remember, deal with that exponent first. Okay? And we know natural log of e to the x, it could cancel out, but let's see how this plays out before we do that. So I'm going to leave it alone just for now. I know this is going to be e squared, and then here was my e to the fourth. I'm going to leave it and not cancel it because I know I can use my subtraction property here. So I'm going to make it e to the x over e squared equals e to the fourth. And properties of exponents tell me that I could subtract these exponents and make it e to the x minus 2 equals e to the fourth because these two pieces have to be the same. So x minus 2 has to equal 4 and x is 6. Right? Using a lot of properties that we saw where if things have the same log on the outside, we can just kind of drop it away. Or if it has the same base, we can just kind of drop it away. You could have also from here kind of gone this way and said, well, if I made this natural log of e to the fourth, natural log of e cancels out, so I'm left with x minus 2 on this side, and natural log of e over here cancels out to give me 4, and you get to the same spot. So you can use the properties in a lot of different ways. Okay, so your task is to finish up the rest of this worksheet on page 26 with the examples. Okay, and that is going to be it. Submit that to Google when you're all done, and we'll move on from there. Okay, good luck.